Number 14. There we go. Second order linear differential equation there. 10 marks, but it's a nice standard straightforward one. It takes a bit of time to go through it, but if you know what you're doing, you can get through it all quite easily. The only problems might occur if either of these clashed with the complementary function. You won't know that until you find the complementary function. But unless e to the x is one of those solutions, or one of those, or 12 is one of the solutions, in that you had e to the 0. So e to the 0 is just a constant. If those were the cases, I'd have to consider x e to the x, and also a linear term, like cx plus d for instance. But unless that happens, for the particular integral, I'm just going to consider a multiple of this and some constant. Right, but I'm just going to rattle through the standard order. Get the auxiliary equation, get the complementary function, get the particular integral by just trying the combination of those, which will give me the general solution. Start putting in these answers to get the final particular solution. So off we go. Right, auxiliary equation, that's going to be m squared minus m minus 2 equals 0. Factorising it from maybe 1 and 2, the negative makes it there, which means m equals negative 1 or m equals 2, so that the complementary function is going to be y equals a e to the negative x, that's alright, plus b e to the 2x, so that's alright. So that's that bit done. Complementary function. Right, for the particular integral, well, I'm going to do this. I'm going to do y equals, I've got a and b already, so c e to the x plus just d. Right, now I need to feed it into this. I've got the y already, now I need to do y by dx. So dy by dx is going to be c e to the x, and the second derivative is still going to be c e to the x. Now feed that into that. That means I've got that one. I've got c e to the x minus c e to the x minus 2 times c e to the x plus d equals e to the x plus 12. Well, there you go. So I've got this. So I've got negative 2c e to the x minus 2d equals e to the x plus 12. So equating the coefficients, that means that you've got negative 2c equals 1. So c equals negative 1/2, and negative 2d equals 12, which means d equals negative 6. Then, so that means it equals negative 1/2 e to the x minus 6 for the particular integral. So the general solution equals, put the two parts together, y equals a e to the negative x plus b e to the 2x minus 1/2 e to the x minus 6. Now, general solution when x equals 0, y equals negative 3 upon 2. Right, so put that in. Right, that means negative 3 upon 2 equals a e to the 0 plus b e to the 0 minus 1/2 e to the 0 minus 6. Right, so that's negative 3 upon 2 just equals a plus b minus 1/2 minus 6, which means a plus b equals, that goes over there and makes that minus 1 plus the 6 equals 5, which I'll call 1. Next bit. X equals 0, dy by dx equals a half. So I'll need dy by dx. Dy by dx equals negative a e to the negative x plus 2b e to the 2x minus a half e to the x, and that disappears. I'm putting that in. So that means a half equals negative a e to the 0 plus 2b e to the 0 minus a half e to the 0. So that says I've got a half equals negative a plus 2b minus a half. So that means that negative a plus 2b equals 1. Negative a plus 2b equals 1. That's my second equation. I have to go up to the top. Back up to the top. Right, pair of simultaneous equations. Add them. 1 plus 2 means I've got 3b equals 6, so b equals 2. And using 1, I've got a plus 2 equals 5, which means a equals 3. Feed it back into this to get the particular solution. Y equals 3 e to the negative x plus 2 e to the 2x minus a half x minus 6. And that was question 14. Question 15. Two lines. Find the values of an unknown k here in that direction vector for which the lines intersect. So it's telling you they intersect. Right, the first step would be put them into the parametric forms so you can equate the corresponding coordinates of the point of intersection. So I need to create a parameter. I've not left myself a lot of room here, so I'll just say I'll let that one be t and let that one be s. S isn't so good because it looks like a 5, but they've done it now. Right, so for this one, for the first one, I'm going to have this. I'm going to have a x equals 1 plus kt. I'm going to have y equals nothing, just negative t. I'm going to have z equals negative 3 and then plus just one lot of t. Same for the next one. I'm going to have not a lot of room, so I'll just have to put it underneath. Maybe it's quite good there actually. I'm going to have x equals 4 plus s. I'm going to have y equals negative 3 plus s. And I'm going to have z equals negative 3 plus 2s. Then at the point of intersection, you can equate the coordinates. Equate the coordinates. I'll not equate them just now because it's got an unknown. Just use the y's and the z's. So that means I've got a pair of equations. I'm going to have from the y's, I'm going to have, which way around will I put it? I've got negative t equals negative 3 plus s. And I've got from the z's, I've got, where will I put it? Negative 3 plus t equals negative 3 plus 2s. So that says t equals 3 minus s, and that one's got, I could just substitute it in now instead of tidying it up, I'll just put it in. That one says I've got t equals 2s. There's a pair of equations, quite easy to solve. Just substitute one in the other. So substitute 2 in 1. So number 1 is going to read 2s equals 3 minus s. So 3s equals 3, so s equals 1. And then using either of them, just use number 2. That means t is going to be 2 times 1, so t is going to be 2. So it means I can find what this k is then, because I've got those two sides should be the same for x. So I've got 1 plus, this is using the x's, I've got 1 plus 2k should be the same as 4 plus 1. So 2k is going to be 4, so k is going to be 2. Then, for the point of intersection, don't put that y in there, just use that for the point of intersection, so let's put that here. Point of intersection, in order to find that, you can choose either of them and put it in. I'll choose s. We'll put s equals 1 into the appropriate equation with parameter s. So that means x will be 4 plus 1, which is 5. Y will be, I will put the equals back, negative 3 plus 1, which will be negative 2. And z will be negative 3 plus 2, which is negative 1. So the point of intersection is going to be 5, negative 2, negative 1. Now that was the first bit. Right, part B, find the angle between the lines. Well, it just goes back to the higher, really, doesn't it? Apart from interpreting what the vectors were. Right, well, there's two lines. Find the acute angle. Well, the thing is, two lines will cross, but there's two angles. So, if you don't find the right one, first of all, just take it away from 180. If you find the right one straight away, that'll be the one. So that's just going to be the scalar product then of these. Now, you knew in the first one, k was 2, so I can replace that. That was 2. So I know the direction vectors for each of these lines. That line, u1, and L, we'll just call it u, has got a direction vector of, just write it as a column vector, 2, negative 1, 1. It's quicker than writing it out as the components of the unit orthogonal vectors. And v is 1, 1, 2. Which means that to get the angle between them, cos theta, maybe I should state that somewhere, so let theta be the angle between, whoops, a couple of these would do, L1 and L2. Then cos theta is going to be u dot v over the length of u times the length of v. So that's going to be, just depends how much work you want to put down for this. I'll do it in bits and pieces. So I've got 2 minus 1 plus 2 over the square root of 4 plus 1 plus 1 over the square root of 1 plus 1. These of course are going to be the same, which gives me for the first bit 3 on top. That's root 6 times root 6, which is 6. So that comes to a half, which means that theta is going to be the inverse cos of a half, which you should know. And if you don't know, you just remember the little triangle that produced them. I know that looks like a 45-degree triangle. That was a bit of a nuisance. So for a 60-30 triangle, that's going to be 2, 1 and root 3. So cos means the adjacent, so that's 60. So the angle is 60 degrees. That was the acute one, so that would do nicely. 16 then. Use integration by parts to show that you get this result here for I to the n, starting with this one. So integration by parts. Right, well that simply means I'll introduce a factor of 1. So I've got my 2 parts indeed. And since that's the part I couldn't integrate, that'll be the bit I'm going to differentiate. So that's the part I'm going to integrate. Right, and I'll just put it over here. Then, so it's going to be integrate that, that'll go up to x, leave that alone, so it'll be 1 plus x squared to the n still, and it's been evaluated, so I'll evaluate that part, minus the integral of, that's been done, leave it the way it was. Now differentiate this part, and that's power negative n, so it'll be multiplied by negative n, then take 1 off the power, negative n minus 1, so that'll be 1 over 1 plus x squared to the n plus 1, multiplying by the derivative of the inside, which is a 2x. I'll put that up here, 2x dx. Tidying that up, well that's still to go from 0 to 1. Well, as I tidy up, I suppose I could put the 1's in. So for this part, it's going to be, I'm going to have 1 times 1 over 1 plus 1, well I'll just show that, 1 plus 1 to the power n, minus, then it'll just be 0, minus integral from 0 to 1 of, then I've got a 2 and a negative making a plus 2 and an n, and then I'm left with an x times an x, which is an x squared on top, over 1 plus x squared to the n plus 1 dx, and then that part's just going to come to 1 over 2 to the n, so equals, so I to the n equals 1 over 2 to the n plus 2n times the integral from 0 to 1 of x squared over 1 plus x squared to the n plus 1, which is what was required for the first part. Right. Now part B, find values of a and b for which this, well you can see where that's coming from. That was the part that you still had inside of the integral. So this is going to split it up and produce things. Not absolute answers, but relative answers for the recurrence relation. So it doesn't matter, all it says is find A and B, for which that's true. So the first step would be just multiply it through by that denominator. They all divide into this one. So that just means it would have A times, it needs one more of those, so 1 plus x squared plus b equals x squared. And then just compare the corresponding coefficients. So if you compare the x squared terms, I've got ax squared equals 1, which means a equals 1. And if you compare the constant terms, I've got a plus b equals 0. A plus b equals 0, which must mean that b equals negative 1. So that was the first bit. Right, the next part, you have to show I to the n plus 1 does something. Well, the whole purpose of this point has been to replace this. So going back to that expression that you just got in part A, just start filling what you've got here. So you've got I to the n is 1 upon 2 to the n plus 2n times, only I can split this into those two parts. So I've got 1 over 1 plus x squared to the n minus, because b was minus 1, 1 over 1 plus x squared to the n plus 1 dx. But that was precisely the form of the original in. In is 0 to 1 of 1 over, they both say 1 over 1 plus x squared to various powers, which means that that's 2n times I to the n, and that's minus 2n times I to the n plus 1. So I can replace everything with in's now. So I've got in is 1 over 2n plus 2n times, that part's just in, and that part's in plus 1. And then just switch it over. It wants an expression for in, so I'd multiply it out. 1 over 2n plus 2n in minus 2n I to the n plus 1. Take that over to this side, I'll put that down there. So I've got 2n plus 1 equals 1 over 2n plus 2n I to the n minus I to the n. Getting there, just needs to divide by this 2n now. We'll do two steps in one. So I of n plus 1 will be, divide both parts by 2n, will be 2n, which don't confuse 2 times n with 2 to the power n, plus, that's 2n minus 1, lots of in, but that's to be divided by 2n. And is that what it wants? Equals, so that equals, no, so there's one more step to go, so it was a bit silly, plus 1 equals, because 2 times that is going to be 1 over n times, there's an extra 2, 2 to the n plus 1, plus 2n minus 1 over 2n in. So that's the second bit we wanted. Then for the final part, part C, finally work out something. So you have to evaluate this using the recurrence relation just established in parts A and B. So, well, that stands for I3. So you have to work out I3. Well, this is a recurrence relation expressed in terms of the previous one, just like your ordinary and your recurrence relations. So it means I can express it in terms of I2. Right, so, but that means that n plus 1 is going to be 3. So that means I've got 1 over, if 3 is equal to the n plus 1, then n will just be 2. So it'll be 2 times 2 to the power 2 plus 1, which is 3, plus 2 times, and n is just 2 for this one, so 2 times 2 minus 1, which is 3, over 2 times 2, which is 4. I don't know why I put the bracket there, I think I was going to show more working. I2, so that's going to be 1/16 plus 3/4, you need to go up higher I'm afraid, little 3, of I2, then I just apply the recurrence relation again. So I2 expressed in terms of I1. So in terms of I1, that means I've got 1 over 1 this time, times 2 to the power 2, because if n plus 1 is 2, n is just 1, 1 back to 2 again, plus n is 1, so that's just going to be 1 over 2, so plus a half I1. So what have I got? I've got a 16th plus that part there, I've got 4 3/16 plus 3/8 of I1. But I1, we'll just put it back in again, is 0 to 1 over 1 plus 1 plus over 1 over 1 plus x squared dx, which you should recognise, inverse tan. So I've got 4/16. 4/16 is a quarter plus 3/8 of inverse tan x from 0 to 1. So I've got a quarter of 3/8 of inverse tan 1 minus inverse tan 0, and we're going to have enough room here, a quarter plus, depends on what I want to write down. So that's going to, 1 goes back to 45 degrees radians, pi upon 4, of pi upon 4 minus 0. So finally I've got 1 quarter of 3 over 32 pi, plus 3 pi over 32 for I3. And there endeth the exam.